others would. Okay, so as I've said, basically in today's session, we'll be checking or diving into functions in Python, understanding the rationale of function, the logic behind function, why we need function as programmers, also understanding parameters and arguments. So in arguments, we have what we also known as the keyword argument. We'll be checking that. We also have what we also known as default arguments. So you would, and afterward, you'd be going to the lab and having some hands-on practice to understand how this works practically. So without further ado, so I will be launching my VS Code now. So when we say function, right? So what do we mean by function in programming or in Python as a language? So basically, function allows us to reuse a block of code, right? So again, so function is just like a reusable blocks of code so that perform specific tasks. So again, it is a reusable blocks of code that performs specific tasks. So how do I mean, or what does this translate into? If, for instance, we are writing a program or we are developing a solution. So in this solution, we need an output. We need an output repeatedly in the course of our program. So for us to achieve this, we can just basically code this in a function block. So now every time we need it, we just need to invoke or call that function. So it is needless to be writing that same lines of code to achieve the same thing again. So once we define it, so all we need to do subsequently is to just invoke that function, then it gives us our desired output. So that is why it is universally known to be like a reusable block of code that perform specific tasks. So this is one of the importance of function, right? So another thing of function is just like saying it as like having like a manual book, right? Like having a manual. So a manner that you can just hand to anyone who needs um, instruction on how to perform specific tasks or action that you don't need to go and be explaining to them over and over and over. This is how to do this. You just hand it over to them. Anytime you need it, just run this. So it achieves desired output. So that is what function does. So now this function has convention, right? So how do we now define a function or how do we write a function? So we start by writing function by using the keyword def, right? So def, which is an acronym for definition. So it stands for, okay, fine, no, your interpreter or your console now understands that what is coming afterward is what? Function. So we want to define a function. So the first keyword we use is def, right? So after using def, the next thing is our function name. So, and here it is recommended to always use a descriptive name, a name that would make our code readable and that would also make it instructive, right? So let's say, for instance, we want to write a function that adds two numbers together, right? So in our program, every time we need a function, or every time we need a functionality to add two numbers together, so we just call that function, right? So anyone also reading our code or going through our code snippets, so upon seeing our function name can, without us having to tell them what it does, they have an idea of what the function does. So by giving it, let's for instance, we want to write a function that adds two numbers, right? So by saying our function name is add. So anyone that sees this function name have an idea of what this function does, right? So this is why it is encouraged or recommended to use a descriptive name for function while naming your function. So now the next thing is to add a parenthesis. So a parenthesis, right? So after the def keyword, we give our function a name, and we add our parentheses. So in this parentheses, there are a lot of other conventions attached to it, right? So which we'll be checking in detail in a minute, right? So now, but basically, to define a function or to start a function, so this is the things we need. So following the parentheses is what we know as the colon. So when the interpreter or a compiler sees this, it understands that, okay, oh, the next block of code that is coming after this is what? A function definition. So we have said that our function is defining, it's used to what? To add two numbers together. So in this case, we can just say that if we want to just define a blank function, so you can just say to allow you to move past this, so you can just say pass. So when you say past, you can actually go on and be doing other things in your body of what environment where you are what writing your program, right? So in this case, this is accepted as a function, but it would not just like perform any activity or any function. So now let's say for instance, now let's assume these are function definition. We are still going to write an interactive function, right? That will be able to tell to perform specific actions for us, right? So now let's now assume we've defined our function, we've defined everything we want these functions to do. So what is the next thing? The next thing is to call on this function. So in other words, invoking a function. So how do we invoke a function? We invoke a function by calling the function name, in this case, add, and adding the what? The parentheses. So everywhere we do this, the interpreter understand that we want it to carry out the assignment we've given it. We want it to carry out the assignment we've given it in the what? Function block of code definition, right? So had it been we've defined an activity or a functionality for these functions to do, once I call that add and the parentheses, it was executes anything I instruct it to do. We are going to see that in a minute. So in brevity, so this is just like a syntax for defining function in Python. So now let's now assume we want to print this, even though it is an empty function. So let's say, for instance, I now said that this x is now equal to this, right? So let me now say this x is equal to this. So if we can still remember, we don't have anything defined in this function. So we just want to run. So let's now say run. Can we see what did this print on the terminal? Can anyone confirm if you can still see my screen and if you are still with me? Can we see what is printed out in the terminal?
Yes, yes.
Can anyone confirm it? What do we have there?
None.
We have none. Thank you so much, because we didn't define anything. But basically, this is the syntax for defining a function. Now, let's now assume that we want our function to be able to perform specific tasks for us. So function is basically used many a time for automation, right? To avoid repeating the same thing over and over, to avoid manual intervention in the course of what? Taking user data or trying to output something for your end user, right? So if function can come to our aid and help us to do this seamlessly. Now, let's say, for instance, now, so I want to use an example that we can all resonate with. So let's say, for instance, you want to sign in into an application, right? So in this application, so you would all be familiar with this analogy. Once you enter, for instance, let's say you just enter a name. In this case, you want to sign in, you now said that, okay, you enter your name as what? Damilola, right? So after entering your name as Damilola, so it takes Damilola as your what? Input. So let's compare this as us also taking what? Data, using the input function to extract data from end user. So now after taking this name, Damilola from user, we want to greet Damilola. So we want to say, hello, Damilola, right? So now in this case, Victor is also using the same application, right? When Victor is also signing in, once Victor also input his name as Victor, you want it to also print hello, Victor. We want it to do the same for Rhoda. That is hello, Rhoda. So this is one of the basic responsibility of what function in what Python. So how do we do that? So you can basically do that simply by now going to modify this function we've defined before, right? So in this case, so now I have said before that it is recommended to always use like a descriptive name for your function. So since we want to greet, let's change this name to greet, right? Let's assume we want these functions to greet, right? So now this is where I will now be introducing the concept of parameter. I mentioned it here that you would also be checking parameter in the course of this session. So it would make sense now. So you can see here parameters and arguments. So now what is parameter? So parameter is just like a placeholder, right? It's like a placeholder. It's like a variable, right? A variable standing as a placeholder to receive a value from end user. So it's just like saying, for instance, so let me say, for instance, I want to define, you all agree this is a variable, right? So I define a variable as name. So I now said that this variable, I want the name to be what? Rhoda, right? So this is, Rhoda is a value, while name is the what? Variable. So the Rhoda as a value is kept inside name, which is the variable. So it's the same thing as what we are inserting inside this parenthesis in our function definition. So it is a variable now standing as a placeholder to take any input from the user and display it as output depending on what we ask this thing to do. So now it will all make sense in a minute. So now let's say, let me comment this. So now let's say, for example, so we now call our variable name, right? So we call the variable name. Again, we want to define the function def keyword. We give it a name greets and a variable. So this variable now is the what we know as parameter. So parameter is the placeholder variable that you use while defining your function. In short, it's what a name variable used while declaring a function. So now I have defined my parameter as name. It's a placeholder for anything I will be inserting afterward in the course of my function definition. So now I want to add something to this function. So I will now remove this pass. So don't forget, what I want to add is what any name that I am giving while I call this function, you should just tell the person, hello, blah, 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 right? So now let's now say that, so we don't need this also anymore. So since we are defining something else, so we can actually comment this out. So we want to give life to our function so that it can all make sense now. So when I say enter here, right? So if I now say that you should print, so what do I want it to print? So let me use an F string. Please, in case you have any doubts or there is any question in the course of this session, so please just call my attention anytime, right? So that we can all be on the same page and we can all ensure we are syncing while we are at it, right? So we call it an F string. So I understand, I want to believe we all understand what this F string does, right? So now, and I want to pass my customized message, right? So I want to pass my customized message, which this F string would allow us to do. So I can say hello. Can you see now? So hello what? Hello what now? So I want to say hello, anything that the user so anything that the user enters as what? As name. You remember I said this name is a placeholder, right? So now, hello, anything the user inputs as what? As name, right? So I want to say hello, blah, 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 right? So now after this also, I want my function to now print another thing. Let's say, um, how, how are you doing today, right? So after giving us a custom output, I also want it to say, how are you doing today? So, and before saying that, how are you doing today, I want it to print a new line. So this is what this does basically, to just print a new line, right? So now let's assume basically, this is all the things we want for our function to perform. So function can be complex, right? Can also take complex logic or complex operations, right? So, but just for basic and for fundamentals. So let's assume this is all we want our function to do. So we've defined a function now. So now let's invoke this function. So it is another concept that should also be um, we should all be cognizant of. So it is what? Invoking a function. So for function now, anytime we now need it, so that is when we now call the function. So here we can say that, um, so now I want to pass this function name into a variable so that we'll be able to print out that variable, right? So this is because we are using a text editor. So if I was on a Python interpreter, I don't need to pass it into a variable before invoking a function. So I would also give us an example of that so that we can understand the difference between them. So basically what I'm doing is because I am typing it in an editor, right? So, and I have to give it a full description of everything I do for it to understand what I want afterward. So now let's say that I want to give this, I now want to pass this function so into a variable. So I will now say x is equal to, so I will now call it greet, right? So now this is how to call a function. Now in this case, now this is where we now add a name, right? So don't forget, I said the name variable we defined earlier is just a placeholder. So this is where you want to add the name. So you can now say here that Victor, right? So we've called the function. So which means every time I want it to greet someone, right? So once the person enters the name here, I want you to take that name and assign it to that variable placeholder we defined earlier. So now I can now say that what print x, right? So print x means now execute this function, right? So now let's see what we have here. What do we have here on the screen?
Hello,
We
Victor.
have hello, Victor. How are you doing today? Right? So do we see that we have hello, Victor. How are you doing today? So now let's assume that, okay, in this program, so I want, after Victor, Rhoda is also using the same software application. So when Rhoda also inserts a name, so let's see what it prints. We also have what? Hello, Rhoda. How are you doing today? So same thing with, let's say Damilola. So we have what? So when we run it, we also have what? Hello, Damilola. How are you doing today? So this is like typical to what we experience while signing into. So let's say, for instance, maybe our mobile banking app. So after signing in, right? Because we've registered before, so it asks your data. So now let's say that blah blah blah. How are you doing today? Good afternoon, good morning, as the case may be, right? So this is one of the um, things we can use function for. So this is one example. So I mentioned something that if you were working on Python interpreter, you don't actually need to be saying this x is equal to assigning it to your function before you invoke it. So basically, to call a function, you just need to call that function. So since our function is greet, just say greet parenthesis and the name, right? Greet parenthesis and the name. So that is what it is by convention. So okay, so let's now check another example of a function. So now let's now assume we want to define a function that um, we can always use. Let's say, for instance, you are a math teacher, right? So in this instance, you are a mathematics teacher. So as a math teacher now, you deal with of um, areas of a rectangle. Is it which of these do we use this formula to find? Is it rectangle, or I think it's rectangle. This length times width. That should be rectangle, right? Can
Right.
anyone confirm?
Yeah,
Rectangle, right?
yes.
Thank you. Yeah, thank you. So now let's say you deal with rectangles a lot, right? So you now you want to design a software that is, so by default, once you just enter what width is, you enter what length is, it will just tell you the area of that triangle, rectangle. So without having to rack your head to solve that. So we can also use a function for that. So now let's now say you want to define that now. So we now say what? So let me comment this. Okay, so now let's say that this function is designed to help us to check the area of a rectangle. So now I'll be using my terminal now so that you can have the experience of the other scenario I was trying to paint. So now I'll be going to Python. So once I enter py, right, so I am in Python interactive mode now. So as we can all see on the screen. So I want to define the function. I'll say def, right? So a descriptive name we can use in this case is, since we are finding area, so you can call it area, right? So you can see our function name is area. So now don't forget, we need two um data for us to get the area of the rectangle. That is, we need length and we need width, if I'm right? So which means basically we need to define both as the variables while declaring the function. So here we say length, right? So after length, so we add a comma and we say what? Width. Then we close our parentheses. And don't forget your what? Your colon. Otherwise, you would have issue with the interpreter. So this is what defining a function. So what do we now want this function to do for us? So we want it to, when upon giving two data, two integers, that is two numbers, a number for length and a number for width. We don't even care how you want to arrive at the um, solution. Just print out the result for us. So in this case, so this is where we can now use the return function. So if you also notice, it is very instrumental in function declaration or in function definition, this return. So in this case, you can now say return. And you see, return. So it is very simple. What is the formula for finding the area of a rectangle? It is what? Length times breadth.
Right.
Is what
Yes,
length times width, right? So yeah, we just say return length, right? Times the what? The
wait.
width. Yeah, that's it basically. So which means every time we call this function and I give a data for length. Don't forget, this length is what? Parameter. I mentioned that earlier.
Yeah.
This width is also a what? A parameter,
Mm.
right? I mentioned that earlier. So now I would now be mentioning what argument is in a minute now, right? So because they work hand in hand. So now let's say we've defined this function. So that's all we need to do, right? So because it's just a basic function. So now let's invoke this function. As I've said before, so you don't need to define extraterritorial variable x to assign. No. So right now, just call the function name. And that is one of the importance or benefit of what? Of using function in your program. So now you can say area is what? Now, the data now replacing the variable is what we now known as what? Arguments. Do you get it?
Yes.
Initially, we defined a placeholder for variable using parameter. Now, giving data for that parameter is where we now use what we know as what? Argument. So argument is just like a keyword for it, right? So now in this case, now let's assume, what should we call our length? Let's say our length
Fine.
is 5, right? Okay.
Yes.
So if we say our length is 5, so now let's now say, don't forget this takes two arguments. So
Argument. Yes.
I'll be technical now, right? So it
Yes.
takes two arguments. So I believe we know what argument is now. So it takes two arguments. So our width should now be what?
4.
4, right? Okay, now let's say our width is 4, right? So we've invoked, so when we say enter, so let's see what happens. What do we have on the screen? So
20.
it's print out for what? 20. So basically, anytime I need to find the area of a rectangle, what I need to do in my program is just to write what? Just to call area and supply the arguments in the
Okay.
parentheses. I am fine. I don't need to bother again. Now imagine if we have like a complex program that we have defined in a function, right? So now imagine how easy this would be for us to use it repeatedly in the course of our what program. So this is
Mm.
basically what function does. Now, another thing I want to mention in function is there is something also under function. So let's say, for example, we want to use a keyword argument, right? So a keyword argument. So let's say, for instance, now what a keyword argument is. I've said what argument
Sorry,
is,
please,
right?
can I ask a question?
Sure, sure, sure.
Okay, in this return, what if I don't want to do product? What if I want to do addition? If I put length plus, it gives me back whatever. Does it necessarily have to be like when you're doing like the area, usually
Yep,
is
yep,
multiplication,
yep,
right?
yep.
What if I don't want to do multiplication in the area? What if I want to do addition?
Yeah, thank you so much for that question, right? So the answer is not far-fetched. It takes every arithmetic operation. It
Okay,
takes every arithmetic operation. It depends on your own objective as a developer. So let's say, for instance, your
okay,
own program is maybe it involves, it can even take like cross arithmetic, like
yeah,
maybe it's a formula. Like in our last session now, we built a
yeah,
software. In our last session, we built a software that we used to convert temperature from Fahrenheit to Celsius. And for us to do that,
okay,
we had to what come up with the formula. So in that formula, we have like complicated operations that we added together to
right,
get that formula. So in this case, if you want to define that formula in a function, so we can use a mix of all those arithmetic. So it's not like it doesn't differentiate, it allows everything, right?
okay, okay.
Exactly. Yep. So now having understand what parameters is, what argument is. So there's also another thing also known as what keyword argument, right? So keyword argument is very useful in a case whereby we have let's say we have multiple parameters. So if you have multiple parameters, in order not to confuse our outputs, right? While giving this argument, so we can make use of what we know as keyword argument. So for instance, let's say I want to invoke this same function again, that is this area. So what keyword argument just basically mean is just like typing what the parameter is and assigning what? Assigning the argument to it while calling, while invoking. So in this case, we can say what initially we just call it and said 5 and 4, right? But if you want to use keyword argument, maybe if you are someone that is very big, right, on code readability, right? So you might want to like this approach. So you can just say, in this case, you can say length is equal to 5, right? So,
Right.
and you can now say what width
With
should be equal to what?
4.
Should be equal to 4. So it's just basically the same thing, but what? Just declaring or defining what is in the course of our what invocation. So when I ran it, what did we have? We still got the same thing. Can we see that?
Yeah.
When I ran, we still got the same thing. Do you get?
Yeah, I get both. So I wanted to ask, does that nullify the parameters we wrote earlier? The length and the width.
Yeah, does it nullify the return?
No, no,
That
no, 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 no. Because basically, no, let me use this to answer your question so that you can understand it better. So now let's now say I want to call a parameter we did not define while we were defining our function. So now let's say in this case, I now say breadth. Breadth is equal to, this would answer your question in a moment. Breadth is equal to let's say breadth is equal to 5, comma. Let's now use the one we defined earlier and say length is equal to 4 in this case. Now let's see what happens. What did we get?
error.
Now let's read this error so that you can have an idea of
Okay.
what we are doing
What
wrong.
happened?
Area, can you see? It returned
Yes.
that area for us. Area, this function we are calling, got an
Mm,
unexpected keyword
yes.
argument breadth.
Breadth.
Why? Because we did not define breadth while we were
Eh,
writing our function.
Oh, okay. It's always important to define our
As
parameter.
Yeah, so you must
yeah,
define it.
no. Parameter is not compulsory, right? It's optional. But if you want an interactive function, you need to define parameter. For instance, this is a parameter. This is also a function. Let me say a function without, I can just say def. Let me call this, let me give it a name. Which name can I give it? Def, and say, okay, let's say greet also. Let's say greet too. Let's say greet too, right? So I won't give it any parameter. So I just say def greets, right? So now, but in the
Mm,
print function, so anytime someone calls this greets, I just want it to greet the person. Hey there. Uh, what's what's the weather like? So just for instance, right? So can you
yeah.
see I did not like impute any
Give
parameter.
anything.
So
Yeah.
what this one does is what I
That's
just
all the
call this
question.
greet. What did it print on the screen for us?
AJ, what's the weather like?
Can you see? But what is important is, but if the case you now use a parameter, right? Anytime
Mm,
you are using arguments, right, to give data or to give value to that parameter, that argument must be what?
okay.
That argument must be what?
Define
Align,
that.
be defined. So in case you are using a keyword parameter, right? A keyword argument rather. So
Mm.
is there any question before we move on? Okay.
Mm.
No, I'm good. Thank you.
All right. So the next
Um,
thing
I
is
want
also, you said what, Victor?
I want to ask.
Okay,
Um,
go on, please.
so literally you added okay, literally you said when defining a function, right?
Okay.
Then you added the return function. Okay,
Mm,
it's possible. Okay, I think you should buttress the point where it's possible to create a function without adding the return. the return what's the name statement inside. Like I want you to explain to them that I want you to explain to others that they can also create a function. They can also define a function without adding the return statement inside.
Yeah, I think we did that earlier. So for example, we've done that earlier. Let me fetch that snippet where we did that. So for example, in this function that we used as our first example, so in this case, as you can see, we used a parameter, right? And we use this to customize our greeting for individuals that is signing in, depending on the information we get from that individual. So in this case, we didn't use return. Can you see? So as he rightly said, so it is not compulsory that we must use return, right? But return basically, it can be used like in different cases, but it is useful primarily when we are like dealing with operations like arithmetic. So it is very instrumental when we are doing this arithmetic. We can also use it like plainly, but it's mostly instrumental when we are doing this arithmetic. So we can just say like it makes our code short and fast, right? So if I had want to, like, let's say for instance now, so let me use this example again. So let's say I want to define a function to find area of what again? Area of the rectangle again. So I can say something like this, right? So so I need to define parameter, right? So I can say that here we have length. So this can actually take anything, right? So you can call your length anything, but should just be conscious of the name so that it can be what descriptive. So we say what length and we said what width. So now, and I want to define this function. I don't want to use return in this case. So I can now say that in this function, now let me now define, I want to calculate how to find the arithmetic, right? So I can now say that, um, let me call this, okay, let me say, let me
Hello? Please, can anyone hear me?
Yes, I can hear you.
Ah, I know fear. This
I
is not
think
my
his
list.
network. I think his network went off.
Okay. Yes.
Or maybe the 1 hour is up. I don't know, or 45, 40 minutes.
One hour.
No,
Was
you know
not
Zoom.
1 hour.
Zoom is actually 40 minutes.
45 minutes. But if it had gotten to 45 minutes, it would just
We'll
send
be
every.
logged out, right?
Mhm. Hopefully he joins back.
Um, Hi guys. I can you all hear me?
Yes, yes, yes. One, two.
Um,
Yeah.
Sorry, I was thrown out by network, so I had like little issue trying to reconnect. So okay, sorry about that. So let me share my screen again. Okay, so basically, as we were saying, right? Let me check. So let's go back to the terminal. So now, can we all see my screen?
Yes,
Awesome.
yes.
So now, as we were saying, now in this case, so I don't want to use the return function here, right? So I don't want to use return here. So I just want to print this out. So without the return. So I can just say what? Print what for me. So in this case, I will just say print area, right? I just wanted to print area. So I would have loved to actually do it here so that we don't need to be defining um, another variable to print out our output. So now let's say print rect. So let me try and clear this first so that we can have a clean screen. Okay, so now I want to define a function that checks the area of a rectangle. So Olayinka, thank you for joining. So we've been on for almost an hour. So we've had a lot of discourse and we've had a lot of examples. So before joining, but we have a recording, so you can actually refer to that after the session. So yeah, so I said I have defined my, I am defining my parameters, right? So I want to use length and I am using width. So in this case, so as a refresher for those who are just joining, so to define a function, so all we need to use is to what? To have to use the keyword def, right? And to give our function a name. So in this case, we are calling it rect. So and after that, we use a parenthesis. So in this parenthesis, we define our parameters. So and followed by what? A colon. So now in this case, I don't want to use a return function as what we were citing before the network glitch. So I can now say here that the area which I want to calculate, so I'm giving it a variable now, right? Should now be equal to length times what?
Right.
Times width,
Always.
right? So now, yeah, I now want you to print the area for me. So every time I call the function, just print this area for me, right? So now let me call the function. So I will now say rect. So now let's give it the
Right.
argument, right?
Actually,
So argument now,
yes,
let's
yes,
still use the same figure we've used earlier. So now let's say 5 and 4. So now let's run it. Do we see it now?
yeah.
So now let's now compare this to the earlier version we had, why we just used return. So
Mm,
return gave us like a shorter what lines of code,
mm, yeah.
which is almost or always preferable. Like if you can, it is always recommended if you can write a code, a program with 2 lines to use that approach than using the same, like writing the same program and having to repeat yourself. So it is called dry in programming, like do not repeat yourself, right? So like writing clean code. So that's about that. So you also mentioned what um keyword argument is, right? So now there's another argument I would like to introduce to us also before we move on to the next topic. So which is default argument. So I think I have it listed in our team. So our default argument is in the case of default argument, right? So this one, all we need to do is to just define it like we define it together as we are declaring our function. That is why it is called default. So let's say, for instance, we want to write a program that greets someone, right? So now let's now say that, but in this greeting, we want it to be custom. So the custom in the sense that, initially we said hello, which has been programmed, but in this case, so I want it to be, it is your own discretion. You could use I, hello, a, dear, and the likes, right? So now, in this case, we want it to be flexible. So you're writing a flexible program. So now let's now say we want to define it. So now we'll be saying, so this will be our last example for argument before you move on, for functions rather. So for default argument, right? So you can say def. So let's call this also greetings, right? So the first thing we want to use as our parameter is what? Greets, right? So now after greets, so this greets would be replaced by your choice of greeting. Don't forget. Now the next one will now be the person you want to greet. But in this case, if we define a parameter and giving it an argument at the instance of declaring our function, it makes it a default argument. You will understand this in a minute. So now let's now say we want to give this an argument of u, right? So you say u. Do you see what we did here? Initially, we've not tried this before, right? But this time, in this case, we are giving it, we are providing an argument for the parameter while we are defining our function, right? So don't forget our colon, right? So now we move on to the next line. So now what do we now want this to do? So we want it to print. So now let's use want it to print something for us. So now let's say, so now let's use F string here. I want it to print, the first one should be, the first thing to print should be what? So print this, okay. And what for us? Let's say this one will be, what would this one be? Greet, right? Are we following? So this one will be greet. So which means anything we are getting for greet should be what? Be replaced by this. Then followed by what? The next one would now be what? So let's say we have a comma. So the next one will be what? What do we have there? We have name, right? So let's say that's all we need. So we can actually make it more elaborative, right? We can elaborate it, but let's just make it basic. So let's assume this is our definition, right? So now in this case, if I call this function, right? So I want to ask you, expectedly, how many arguments do we need to provide? How many arguments are we expected to provide if you
Just
want to
one,
call this
just
function?
one, just one, just one. The other one is default, so it will come up by itself automatically.
Thank
Just
you.
one.
So in this case, if we give only one, it fetches the other because it is defined by default. That is the benefit of what? Using a default argument. So you can just say here, you can just say hello and just close it like that. What happens? Hello you, right? So now let's say what again? Okay, fine. I don't want to use hello. I want to use a. So what do you have there? AU, right? So now, as if that is not enough, right? So even for the fact that we have given it a default argument, it still allows us to still replace that argument with our choice of what? Name. So let's now say in this case, I now want to use someone's name, right? So now let me now say ADBC, right? So now this is what you see basically when you receive emails most time. So you just see it by default. You just state there ADBC, right? No one is sitting in front of a computer and typing it manually. No one is typing your name manually. It is what a function call. So now let's say I'm sending email. So I have taken Adebisi's first name. So I want to send this to him. I'm sending multiple emails to multiple recipients, right? So I just say what? So what do you have there? Dear Adebisi. Can you see that? So default argument allows us to either use a single argument or double argument. This is not allowed if we had not defined it to be default. In a case whereby we add two parameters defined without giving it a default argument, if we want to invoke it and provide one argument afterward, it will throw an error. How do I mean? So now let's come back to this one here, right? So now let's now say here we have defined it, right? So we have how many, we have two parameters, right? If you want to invoke this, if you supply only one argument, you throw an error, right? So that's basically on function. So you can actually use function to do a lot of things, right? While building a program or a solution. So it depends on what you want to do. So any question on function before we move on? Any question, please, before we move on function? I hope we've not lost our earlier recording.
Please, I want to ask.
Okay.
Is positional arguments not to be explained?
You said?
Because you've explained keyword argument and default argument.
Okay. Yeah, positional argument is the first example we cited. Yeah, that was the first example we cited. So in this case now, this is a positional argument. So it was what I was referring to as a placeholder because we have positioned it. Yeah, I can hear you.
Okay.
I can hear you, Victor. I can hear you, Victor.
Okay, so I was saying positional argument as well, because in the, what's the name? In the module, we're giving majorly three types of arguments: positional, keyword, and default, right? And
yep.
which they explained, let's say, they just shed some light on it. But now, positional, I got to understand that positional argument has some criteria to meet before it can, what's the name? Before it can go as the function. So please, I want you to also explain one or two things about positional argument and criteria it should meet before you can call the function.
Yeah, basically, positional argument is just a case of this example we have here. So if you can see my cursor here. So if we define a function and give it like a parameter, right? So now, while we are calling that function, providing an argument will be taking place of the parameter we have defined earlier. So the criteria or the requisite is just that, just ensuring that in that case of using it as position or replacing it in what was serving as placeholder for it, ensure that you used required and expected numbers of arguments needed or that you have previously defined. So what do I mean? So let's say, for instance, now, we want to define another function, right? So one moment, let me try and clear this. So let's say we are defining another function now, right? So let me go back to Python. So in this case, I want to think of something else. What else can we do? What else can we do? What else can we do? Okay, let's make it basic, right? So now let's say we want to define something. So what should this one do? Or we want it to, okay, let's say a loop. Let's say we want to try a loop function, right? So in this case, you now say that what are we looping self? Maybe we want to loop 1 to 10, right? So now let's say def number. So here we call it n, right? Are we following? So you want to loop, right? So we now say for I in range, n, are we saying it? For I in range n, so you want it to print I. So now let's call it, if you say number, in this case now, don't forget number, I only define one position as my parameter, right? Now in this case, now let's say I now want to call this function. I now say 10 and what? And let me supply another number. 10 and let me say 12. So what happens? Can we read that error? Number, which is a function, takes one positional argument, but two were given. Do you see that? Because when I define it as what? Take one. Position means like temporarily holding place for what I will be providing afterward or later or subsequently, right? So now in this case, I defined one, but I'm giving two. We had an error. The error is what? This function of number takes one positional argument, but we are giving what? Two. Now okay, now I now want to debug. Okay, fine. What do I do now? So I will now call my function again. My function number, I will call it again. I will now say number, then now put 10. What do you have on the screen? Can you see now? This is another importance or another benefit of what? Of function. Now, in any time I need to print 1 to 10, I don't need to stress myself. I'll just call that number function and put, it's not even 1 to 10. Anytime I want to print a number, right, from a certain number to a certain number, I'll just put that number on the what? Inside the as argument, as the positional argument, and it print it out for me. Okay, fine. I'm not even fine with this function that I defined. So I want it to be something like, I want it to print this number on a straight line, right? So now let me define it again. So I'm defining it again. I will say, I've lost this. I'm trying to bring it back. Okay, for I in range n, right? If you feel confused, please let me know before we move too far. So okay, fine. For I in range I, so I want you to print I for me. I can't find I. Okay, so since I can't find I, so I will just type it myself. Print I, but while you are printing this I for me, I don't like it in a long list. Every time you want to print for me you on a straight line. So we can all remember this end, right? So and add a space in between them, right? So can you see our function is taking more responsibilities now, right? This is how you can define your function. It can do a lot of things for you. Depends on the criteria or what you want, right? So now, okay, this is everything I want. Okay, now I want to call my function now. So now let's see what happens when I call it. So I will say number. Okay, let's use 10 again. You can use anything actually. So let's say 20 now. So can you see what we have on the screen? So I have from 0 to 19, which if we are all fine with how a for loop range works, right? So we understand that it prints from 0 to and excluding the number specified. So in this case, if you put 5, it prints from 0 to 4. If you put 6, print from 0 to 5, as the case may be, right? So that is that on that. So I hope I have been able to answer your question, Victor.
Let's move on. Let's move on.
Okay, so that is positional arguments. That is what it does. So that's just the basic criteria, right? So making or provision for the same numbers of arguments that is defined as parameter, right? So that is it. So basically under functions, we've been able to understand what functions are. So we also now have a broader view of why we need a function. So we've also been able to have a hands-on practice on how to define function. So we've also checked the likes of keyword arguments, default arguments, and positional arguments. So I would have loved us to also check lambda functions now, but I'll be skipping that for later because of time, because we also need to venture into data structures, and time is fast spent. So as we all know, data structure basically for Python. So we have the big four, if I'm right. So you have the big four, we have the likes of lists, we have tuples, we have sets, and we have dictionary. So and all this, I'll be very fast now because of time. So time is fast spent. We've spent over an hour already, so and we still have a lot to cover. So I'll be speeding up a bit, but irrespective, if there's any question, just call my attention. So now let's now move on to data structures, right? So now what are data structures in Python? So basically data structures are just like a way of having an organized program. So it's just a way of organizing a program in order to have a structured data, right? So if for instance now you would be working on like grand scale projects that will be taking mass user what data. So now how do you construct all this data? How do you collect this data? How do you store them? Right? So this is where we have different approaches that you can do that. So we have the likes of lists. List has its own rationale, right? And logic, right? So as well as tuples. So we have the same for sets and also likewise dictionaries. So all these structures in Python, so they might look alike to an extent, but they have different operations. So now we'll be starting with lists, right? So yeah, so in our team, let's revisit our team again. So in our team, so that I state it here, where is it again? Okay, so now we are done with functions, right? So now let's move on to data structures. Okay, why this is taking time to put up? Okay, so we have it here. So now data structures are used to organize and store collections of data. So I have rightly said earlier, right? So we have lists, tuples, sets, dictionaries. So we'll be starting with lists, right? So now what do we understand by list? What is list? How do we know that in this case, we need to use lists? Tuple. In a different scenario, I think the best thing is sets. Okay, in this instance, I need to use a dictionary. How do we know? It is by understanding their words, individual rationale, and logic of operation. So for lists, list is defined to be like an organized, right? An organized, mutable words data structure, right? It is known to be what's organized and what's mutable. So when we say mutable, so we understand what mutable is in a minute. So let me go back to my playhouse. So now let's just say we want to create another one for, okay, we can actually still make use of this. So let me just comment all this. So now the first thing we need to understand or appreciate while working with lists is understanding its syntax, right? So now what is the syntax of list? Having understanding of what list does, right? So list is also another measure we can use to collect data, to organize data, to store data, right? So now what is the syntax for list? So let's say, for instance, a list can also be stored in a variable. So in this case, let's say we are taking a list of, let's say, courses, right? So we are writing a program. So whereby we need students to give us the information of their, is it, let's say, okay, let's say courses, right? So let's say courses. So let's still go with courses. So we need a student to give us all the courses he is offering in a semester. Now imagine if we don't have like a container where we can store all the courses provided by Victor, in order not to mix it up with the courses that will be provided by Robert. So in this case, you can now have a variable and take all the courses, or in other case, it could be all the courses for all the students, right? But we want to ensure we store all these courses together in what? In a storage, so that every time we need these courses, either we want to go and check the courses we have stored in our database, right? So that we can know what to call, we can know where to find them, and we have everything in a spot. So in this case, we understand that we are working with courses now, right? Now, what is the next thing? So the next thing is we now use what we know as the square brackets. Every time we are working with what? With a list, we use a square bracket, right? It is this square bracket that makes our interpreter, like Python, to know that this database I am collecting will be stored as a list, because very soon we would understand why this is very pivotal and vital. Reason being that once there is like any mismatch in this structure of what we are using to collect this data, it will be translated into another data structure and will not give us the result we want. We're going to understand that in a minute. Now, understanding that we need to define a variable and also having a square bracket, right? So now let's now start collection of our of our courses. So in this case, let's say we want to store 5 courses, right? So we have let's say is three, right? So this is 1, sorry. So we are storing is 3. So and the next one is what? We want to store let's say um computer science. So we can call this comp sci, right? So let's also say we want to store maths, right? So, and don't forget, this list can actually take a mix of string and integer. It is not necessary you mention only string or only data type in your list definition, right? Or in your list collection. It can actually accept mix of data types. But in this case, since we are working with courses, so we all agree that courses are what? Strings. So this is why we would stick with strings. So we have, let's say we also have English, right? So and we also have what we known as let's say geography. So lists now, to work with lists, it's not really as complicated as it seems, right? So once we understand the logic and beginning to understand the logic of lists, we need to first appreciate 2 things. So these 2 things we want to appreciate is, one of them is what? So one of them is what? It is slicing. So we start with indexing, right? It is called index. So these are very like key to knowing your way around lists and other data structures, particularly for lists, right? So because many a time, if you are working with lists, you need to manipulate your way around how you are storing data, how you are dealing with data, how you are modifying data. So, and all of this can be done by understanding the rationale and the logic behind it. So the first one is what? Index. And the other one is what? So let me put it up here so that it won't disturb us. Index. And the other one is also what we call, or we known as what? Slicing. Right? So slicing. So what are these index? What are these slicing? So they are basically a way or a measure to move around our list of items. Don't forget, list is used to collect items together in order to store them, in order to be organized, right? So now let's just say, before we even proceed, let's just say you want to print these courses. If I just say print, now let's see what we have here. So let's say print courses, right? So now let's see what we have on our terminal. Invalid syntax. Why is that? Line 1. Give me a moment. This thing it's misbehaving. Let me try it on this terminal first. Exit. Py. So I'll be defining the list again. So let me just copy and paste it. I want to understand why it's throwing that error. Okay. So now let's say I've defined my list. So I want to say print courses. So do we see it now? It's printed the courses for us, right? So as we can see the output on our terminal. So now, while I was defining list, I said it is organized, right? So now, why is being organized an attribute of list? If you check, it actually printed it out as it is being listed, right? So the first thing we have here is history. If you check our list, we have history. The next one is comp science. We have math, we have English, and we have geography. So this makes it what? An organized data structure. We are going to understand the unorganized data structure when we get to that, right? So, but for this, it printed out exactly as what we have defined. So that is one thing. Now, in this case now, it would now make us proceed or progress to indexing. So now indexing now, in this case, I don't want to print everything out. I want to print only mass out. What do I do? This is where we need to understand how to index, right? How to find our way around list. Now, let's say, for instance, now I am computing results for a student. So I now want to check what is course or what is mark is in maths, right? So if it is possible, I need only information for maths, right? So what do I do? So we now use what we know as what? Indexing. So indexing can be achieved by using this syntax. Now, we call our variable. So don't forget, we define our variable with courses, right? So now we now call that variable back. So when we call the variable, so we now return the square bracket again. So square bracket. So we still need a square bracket. Can you see? So now, this is how indexing now work, right? Indexing, it's like a position that is represented by number, where each item is stored. So now in this case now, this is history, right? It has a number that is representing it like an identifier. In case I want to search for history, there's a number that is lost like an identifier for it. In case I want to search for comp science and the likes. Now for this, the rationale is it now starts with 0. How do I mean start with 0? Is that this history now is represented by number 0. Comp science is represented by number 1. Maths is represented by 2, English is 3, and geography is 4. If I say I want to check the length, if I say I want to check the length of my what? Of my courses, you might be surprised and say, after all, we have 5 now. Can you see? I printed out the length. I'm still going to go into details with that length I just used now, right? So, but if you check, we have 5. How is it that when we were counting, we stopped at 4? That is the convention. It starts with 0 till the last number representing the last item on the list, right? So now in this case, you now want to print history. So as you would have guessed, history will be what? 0, right? If I say courses 0, now let me see. Oh, sorry. Oh, courses, not course. So what is printed for us on the screen? Can you see? We have what? History. Now I want to ask, in this case, I want to print English. Who can tell me the index position of English? Anyone tell me? I want to print English now in this case. What is the index position of English?
2.
You said
2, 2, 2.
2, right? How is it 2? English. Can we check? Can we check again? I am
Yeah.
printing English.
2, 3, 3.
3, 3,
Thank
3.
you. 3. Because we are starting from 0. Say what? 0, 1, 2, 3. So when we say 3 here, and I close my square brackets, if I print, I have what? English. All this would still become handy when you start building complicated and complex programs, right? Okay, fine. I just want to check this. So you just check the position. It's output it for you. It fetches it for you instantly, right? So now another thing also in this indexing is it can also be, we started from the left, right? So if you also want to start from the right, there is also a logic for it. To start from the right, it begins with 0. However, to start from the left, it begins with -1. In this case, if I want to print courses, I would say courses into square brackets of 4, right? So it prints what? Oh, sorry. Why am I saying course? Courses. I have geography. In the same vein, I want to print geography, but I want to start my indexing from the right. So I will now say courses. I said to start from the right, you use what? -1 as the syntax. Let's see what we have printed. We still have what? Geography. Now, in this case, I want to ask you all, I want to print mass, but I want to start my indexing from the right. So what do I use for courses? In my list, I want to print out mass in my list, but I want to start my indexing from the right. So what should be the indexing position for mass?
Minus.
Okay, what do you have in the charts?
-2.
Thank you, Maxwell. Maxwell, thank you so much. So mass will be what? -3. Can you see? Mass will be simply what? -3. Now let's check. This is geography -1, English -2, mass is -3. Now if we run, let's see what we have here. We have maths, right? So that is how lists can be what? Indexed to get a specific item from that list. How about in a case whereby we want to get a sub list from a what? From a grand list. What do I mean? In this case now, I just want to get com science, maths, and English. What do I do? I just want to get com science, maths, and English. What do I do? This is where we need to appreciate slicing. So as I have mentioned above here, as I stated above, what is wrong with this one? So can you see slicing here? So we slice. So how do we slice? Slicing also has its own syntax. So and to understand slicing syntax, so we are going to be stating that clearly here. What is wrong with this? Okay. So now let me say, okay, now this is the syntax for slicing so that we can all appreciate it. So slicing take 3 optional arguments. Again, they are optional, right? 2 is somewhat compulsory, while the third one is optional. However, if we want to use everything, there are 3 expectedly, but 1 is optional, depending on how we want our sub list to behave. So you will understand this in a minute. So now, what is that syntax? It is also represented in a square bracket, right? So in this square bracket, so we can now give these 3 arguments separated by colon. Separated by colon. Now, the first argument will be the starts, right? The second argument will be the end. Now, you should note here that even for the fact that we are stating this as the end, it includes from the starts up to, but not including the end index we are stating. Again, it includes from the starts until, but not including the end index. We are going to see that in a minute so that it would all make sense. So now the last one, which is now optional, is step, right? So before we use everything, let's first use 2, right? Let's understand 2 first before we now proceed to including step while slicing. So now in this case, I want to print from history to English, right? So I now say that the syntax is what? We have our courses. Let me clear the screen. Let me clear the screen. Okay. Is it still visible? Can we please let me know in the chat or you react if my screen is still visible? Can you still see my screen clearly?
Yes, yes.
Okay, awesome. So now in this case, now let's say courses, right? So the next thing we need is our what? Our square brackets, right? So now in this square bracket, I said that we now need to provide 2 compulsory arguments, right? So now in this case, the starts and the end. So now the start, we are starting from history, right? So we can say, okay, so since if you are starting from the first, if you are starting from there is actually a trick here. So please pay attention, there's a trick here. If you are starting from the first item on the list, you can actually leave that position empty. What do I mean? Since we are starting from history, I can leave this place empty. I don't need to supply or provide anything right here. So by default, it picks it from the first item. That's what I mean. Same thing applicable to the last item. If I am trying to print or fetch or pick or build or construct a sub list from a grand list, or if I want to just get everything in that list, right, it is sufficient to define my slicing like this. What I'm saying now is, since I'm leaving the first argument empty, I'm also leaving the other index empty. What I'm telling it is that print everything for me completely. So this will make sense now. If we print, what do we have? Is anything missing on our list? We have
No.
history. If you check our original list, we have history, we have history, we have comp science, we have comp science, we have mass, we have mass, we have everything, right? So because what we sliced is to print from the initial to the what? To the end within states. Now, what if I now want to print from, now what's now happened if I now say courses, if I say courses, I also want to answer this. What would the output be if I say courses one and with my explanation, right? You can also put it in the chat, right? I will check. If I say courses courses 1 and 4, what would the output be? Before I ask Oracle, before I press enter, can anyone tell me? You can put in the chat, you can unmute and answer it. What would
So
the
I think
output be like this?
it's
You said?
I know I'm not supposed to be thinking, but it's maths and English for computer science, maths and
Maxwell, is this for the earlier one, the former one, or this one, or the recent one? Maxwell said all will come out. Okay, we shall see.
computer science, maths and English.
Someone is saying computer science, maths, and English. Okay, we have another thing in the chat. Robert said comp, maths, and English, right? Okay, so now let's see what happens. So I'm going to ask Oracle now. So my Oracle is my enter key on my keyboard. Oh, someone is trying to say something. I think someone has a different opinion. Before we ask Oracle, go, gone. What do we have? We have comp science, we have maths, and we have English. Why? I said it that it takes from the what? From the beginning. We have stated the beginning here is what? 1. Don't forget, history is what? 0. Comp science is what? 1. Right? So we're now taking from comp science, which is 1, right? All through number 4. But while I was trying to give us conceptual framework of slicing, I emphasized that it takes from the beginning up to the end, but not including the specified end index. This is why we did not have geography. It stopped at English, right? If we had wanted geography, we would just simply say what? Courses, states number 1, which we wanted to start from, put our colon. Do we need to state the other index? We don't need it. As the first example, right? If I enter this, it prints out everything for us. And why it did not print everything was because we've said I should start from 1, and history is in index 0. Any question on it? Slicing before we move on? Or index before we proceed? Any question on index or slicing before we proceed? This slicing and index is very they are like their benefits cannot be overstated or overemphasized. If it was not because of time, there is something I would have loved to show us very quickly. Someone said, what if you say one, thank you for this question, or how do I put it? So now what if we say this? What happens? Can anyone guess? Can anyone guess? What if we say courses and say start from 1? We know the items or index is not up to 5, right? But we want to disturb this interpreter. We want to stress it. Okay, now start from 1 and stops at 5, which we do not have. So what happens? It prints what you have for you. Do you see that? I'm going to run it again. It prints everything you have for you, excluding, it will not even bother about that 5. Now let's do something even far beyond 5. Let's say 10. It stops as the what data it has. Right? So I believe this. Okay. Are you trying to say something? Who is that? Okay, I have something in the chat. Okay, so that is cleared, right? So now let's move on. Please, I want us to, okay. Lest I forget, I was about to skip that. I also mentioned that we also have an optional argument or optional index that we can also provide, which is step, right? So as you'd have guessed, step is just like saying that, okay, oh, I want you to print everything for me, but I want you to jump in this number of steps I am what stating or specifying. Okay, to make sense in a moment. So now let's say courses again. We have our courses, right? So you want to slice it, right? So we now say that, okay, start from the first one on the list. So which means we don't need to specify since we are starting from the beginning, right? And I also want you to end at the beginning, at the end rather, right? Start from the beginning, end at the end, but I want you to jump 2 steps. Are you getting the, is it still making sense? Or it's becoming confusing? I want you to start from the beginning, stop at the end, but jump 2 steps. Before I run it, can anyone guess what the output will be for me? Let's use another list so that it won't be as if it is only these courses that are suffered in our hands today. Let's say number. So let's define another list. So let me just clear the screen since we are defining another list. Exits. I don't know. I don't really like this VS Code editor. So this I am using, what is it called? The Python interactive shell. So can you see it misbehaves? Why is it going up now? So let me try and use it now so that everything can make sense. So I can just print it out straight. I'm trying to comment this. Likes to stress me. Okay, fine. Want to define another um list so that we can use it um for the last scenario, which is step. So in this case, we want to say 10. So I have told you the items in our list could be string, it could be integer, right? So this time we are using integer. So 10, 20, 30, 40, 50, 60, and 70. Don't worry, we'll stop at 80. Okay. So now this is our items. It could be score, it could be anything, right? So now we shall know that we have numbers, right? Now in this case, I want to print everything. I also want to tell me the syntax. I want to print everything in this list of items I have here, but I want it to jump by 2. I want it to jump by 2. What would my syntax be? So I have my number here. So I want to index it. So I want to index it, right? So I have my number. So what should the syntax be? Can anyone try? Oh, I have even said the answer self, so no one should try. I've already said it. I wanted to jump by 2, right? So what I was supposed to ask is, what would the output be? So since I wanted to start from the beginning, I don't need to specify anything. And at the end, I don't need to specify anything, but I want it to be jumping, like jump a step, jump 2 steps rather. So I'll just say 2. Do you see it? I'll just say what? 2. Now, if I now print this thing, now let's say I print, print this for me. What would the output be before we consult Oracle? Before I press this play button, initially we have 10, 20, 30, 40, 50, 60, 70, 80. So if I want to use this, what should the output be? So I just want to jump in 2 steps. Do you have anything in the chart?
10, 30, 50, 70.
So we have 10, we have mathematicians in this house. 10, 30, 50, 70. Okay. For me, I don't know at the moment. Someone is saying something. Okay, so without wasting our time, so I'm going to check. So can you see what we have here at the bottom here? So we have what? 10. It keeps 20, right? It jumped to what? To print out 30. It skips 40 and jump to print out what? 50. Skipped 60, print out what? 70. And because the next one is just one item, you just ignored it and give us what? 10, 30, 50, 70. Who is that? Okay, so that is that on that in respect to what? To slicing in lists. So this could be anything. It could be three. We just jump 3 steps, like you are in a hurry. Can you see? We have 10, 40, and it could be anything. If you have something you want to start from, maybe you want to start from 2, you want it to end at, how many do you have? We have 0, 1, 2, 3, 4, 5. I want to give us an exercise now. So I want to give us an exercise. So I want someone to either say it on mute and say, or you drop in the chat what this would print out for us. So we have this. I want to start from this and end in, okay, on one moment, please. I want it to be a bit technical. Um, mm, 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 okay, okay. And let's say we also have 110. Oh, sorry. Let's say we have 110 also. Okay, so now in this case, so start from 2 and end at what? Uh, so end at, let me say, 10 and jump 2 steps. Can anyone guess? Either in the charts or you on mute. What would our output be here? So before we move on, there are still more interesting things we still need to learn in lists as a data structure. List is very interesting and fun to like work with. It helps us a lot while like dealing with large data sets. So can anyone guess this before I press the play button? Is anyone guessing or I should run? Okay, let me check the chat. Okay, we don't have anyone in the chat. Okay, we have something in the chat. Okay, 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 okay. So we are okay. Okay, 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 okay. I am coming down. This one is deep. Someone said, wait. Someone said, calm down. Okay, it's deep. Let's see what we have.
So I think it's 30, 50, 70, 90. Okay.
Hi guys. Hi guys.
I can hear you.
Okay, awesome. Sorry. I want to believe it's like the handwork of some. So he just wanted to seize that opportunity to go and like kick it somewhere. So that was why you had to blow powder. Okay, I see your handwork, Victor. All right, so Victor, I see your handwork. Okay,
Welcome
so
back
now
to Who
we are
Wants to
going
Be a
to
Millionaire.
continue. So I'm going to continue from where we left. Let me find my playhouse again. Okay, so we are asking what else. Okay, let me check the chat. I think I have something in the chat. I also have something in the group chat, right? So what do we have here? Someone said we are going to have, thank you, Maxwell. Someone said we are going to have 80, 50, 70, 90, and 110. Okay. 30, 50, 70, and 90. If not because of time, I would have loved to know your thought process. So how you're able to arrive at this. But to save us time, I'll be skipping that. Okay. So who else has a different opinion? Okay, fine. So not to waste our time, I'll be checking, right? So now let's see what we have here very quickly. Do we still have this recording? Okay, still in. So let's see. Let's play and see. We have what? We have 30, we have 50, we have 70, and we have 90, right? So now, this is where I wanted to create that confusion, right? So I was actually expecting someone to state that one thing. Why? Because when I stated it here, it should stop at 10. Now let's count. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't forget I said that it's check all through the end, but not including the last specified index. Even if you are jumping 2 steps, so you're supposed to jump from 90 and print 110, but because we say we stop at 10, and the convention is don't print the last indicated index. That was why it skipped 110 also. If it had been, we said something like this: start from index 2 all the way to the last index and join by 2, then we would have add this, including 110. Is it clear, guys? Let's react, please. Let's react. Is it clear, guys? Before we proceed, there are still a lot of interesting things we need to like learn from this list. So now we'll be moving on to list methods. So this is where it becomes more interesting. We would have thought that um, indexing and slides is interesting until you understand or appreciate methods in lists. Methods are just like the magic word of lists. Okay, fine. I want to do this for me. I want to do that for me. So what are methods? So methods are like more granular way that we can use to manipulate our items in a list. For example, already I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, blah, blah, blah. I don't need 20 again. 20, I want to remove you. What do I do? Do I need to be coming here and be doing like this? I want to, nope. You don't do that as a developer. What if you've written lines of code? You now want to call back this function like on the 100,000th line. Do you need to be scrolling up, or if it is in a different file already, you need to be scouting around and searching for it? You don't do that. So we have these methods that are very handy in this regard, right? So let me return the comma after the 20. Okay, so now you would start with the first method that is basically very like close to being used mostly when we are dealing with lists, right? So it is the what? The append. So method are just basically they are just basically a defined program that allows us to navigate around the items on our list and modifying them as intended. It could be that you want to add something to your list, you want to remove something in your list, you want to add it at a specific index location on all these as methods in what lists as a data structure. So we have to be starting with append, right? Now in this case, have from 10 up to 110, right? So now let's now say that I want to add 120 to the list. I don't have to come here and be manually entering 120. Nope, you don't do that as software engineer. So you just come here to your what? To let's say, so you're going to remove this. Let's just leave it as number. So you can say, so here we can say um
Mm.
okay, so as I was saying, so yeah, and say number dot what dot append, right? So now what are we appending? So, and I would really want us to place close attention to all these methods, because there are some methods that are closely like related, but they do different operations. They looks the same, but do different things, right? So that we don't mix them up. So we are going to be seeing all of them in a minute. So now we want to do append 110, right, in our list. So I said number dot append. I called the append method. So very soon we are going to understand what all these methods are when we start OOP in Python. So OOP is objects oriented programming, right? So when we start using class, very soon we'll start like writing our program in a class. So this class will be having methods. So now, for instance, now this append now is like a method of either string or list. I'm not really sure, right? It's a method. If you want to understand what method is, by the time we start classes and OOP in Python. So now we are now going to call this append. So you say number dot append. So what I'm saying is I want to add, oh, sorry, we have 110 already, right? So let's say 120 in this case, right? So let's say 120. Let me clear what we have here. So now let me print what we have now. So now I want to say, okay, fine, after appending, print number. So let's have, can we all confirm what we have now? So I have from 10 through was 120. Before now, we start at 110, right? But when we used append, we now have 120. Now, let's understand the characteristics of append. Whenever you use append, it's the new item adds this up. So there are methods that we can use to insert it. But whenever you have been, this does go this for you at the of that list which we have seen, right? That is uh, as dot. Now, another one is, let's say we want to delete some from this list. So let's say we want to delete something from this list. So this thing is already stressing me, this network. Okay, so now let's say now we want to delete something in this list, right? So let's say, for instance, we want to delete, we don't need 20 again, right? We don't need 20 again in our, we want to remove 20. So there's also a method that we can use. So that method is what applies, as the name implies. So it is remove. So whenever you want to remove from your list, just say what remove and you specify that item you want to remove. So in this case, I say but so when what we are so every hour now we are to what is behind all this now. Something that I'm still audible. Can you hear me? Let me know if you can hear me. Am I still audible? Hello, am I still audible?
Your network is breaking, like it's breaking. Can't really hear you fluently anymore.
Okay. How is it now? Is it better now? Um, Hi guys. Okay, so I'll be sharing my screen. Please, someone should please confirm if you can hear me, please.
Yeah, we can.
Okay. So I'll be very fast now. I saw that we react to that in a minute. So I'll be very fast now. Most likely we'll be stopping um on list today. So possibly we can continue tomorrow because of this network. So we still have a lot of things to cover on that list, as well as tools, sets, and Harry. So we're checking all of those tomorrow, right? Just stand up quickly on list. So we have used another method, which is remove, right? So with remove, the aid of remove, we're able to specify a list, an item we don't need anymore. And so one other thing that I did not mention in list is the fact that list can accept duplicates items. So we can have multiple items of the same kind in a list. So how do I mean? For example, let's use our list dots append again. Okay, in this case, let me just introduce another method, right? So let's use insert method. So insert method is used to enter an item into our list at a specified index. Again, insert is used to enter an item into our list at a specified index. Unlike append add it at the end of the list, but insert, if we want it to be a specific place on our list, that is when we use append. So now, how does append work? So append takes two arguments. If you mess our function, should now find what argument is now, right? So append takes two arguments. So say number insert takes two arguments. So say number dot insert. So I will be very fast. Please bear with me. Number dot insert, right? So now the first argument of insert is um the index that you want the new item to be. So now let's say we want it to be at index 2. Currently, we have 30 at index 2. But this new item I want to add now, I want it to be at index 2. Now, let's see what happens. So the first thing you specify is the index, right? So that is the first argument. I have said it takes two arguments. So you say 2, comma, and you now state the value that you want to add in the list. In this case, let's say you want to add 45, right? Let's say we want to add 45. So we want to add 45 at index 2. Now let's print our list and see what we have here. So can we confirm? So we have at index 0, we have 10. At index 1, we have 20. At index 2, we now have what? 45. That is what insert method does. Can you now see the difference between insert and append? Append takes one argument and add it at the end. Insert takes two arguments. First argument being the index number, and the other argument being the position you want. Being the value you are trying to add into the list. So that is that. So another thing I would also want to mention in list, which is equally important, is the fact that list accepts the same attributes, right? So you can have duplicates in a list. So this is what makes lists different from sets, which we'll be delving into tomorrow, right? So in this case, I want to add 45 again. I want to add 40, but this time I want to add it at index 7. So now let's see if it allows us to add it or not. So if we check, we now have 45, we have 10, 20, 30, 40, we have 45. Okay, so this is replacing. Let's say for instance now, let's say for instance we want to add another one. So let's say number dot insert again. Okay, fine. So I want to appreciate this so that we can differentiate between lists and sets. So in index 2 again, I want to add another 45. So now let me print and let's count the numbers of 45 we now have. Can you see we now have 45 at index 2, as you can see here. We also have another 45 at index 7. So which means basically one of the features of lists is that it can accept duplicates, right? So that is that on list. So under I will also be going through 2 more methods, which are also very important in lists, if we call it graph. So I would give room for questions and suggestions and opinions, right? So and then we can call it a wrap. And method the pop is what the pop method. So remember we have used method initially to do what? To remove an item from it. So we have another one which also does this thing. But in this case, in the first one, the remove, right? So remove will state the item will towards delete. But see what happens if I say number dot pop, right? Let me run. What happens? Sorry. I say number dot pop. So what happens if I put my list? Who can tell me what? Can anyone check? So I want us to check what changed when I ran number dot pop. What changed to our new list? What changed to our new list? Just going. You can do up in the chat. What changed to our new list when I ran number dot pop? So okay, we are still coming to address this. What happens to the list when I run number dot pop? Anyone? Okay, so to save us time. So what pop does is pop would remove the last item on the list. Pop removes the last item on the list. There is now one trick for pop. As pop is removing the item, right? It's keeping it. It's not like deleting it. It keeps it, which means what do I mean by it keeps it? If I say, now look at this thing. This thing is very uncommon in list. If I say popped, let me now define another variable and call it popped is equal to you understand what I'm saying now? Is equal to number dot pop. So I want to print, as I'm printing the number, I also want to print popped. It will make sense now. So this is another thing pop does. As pop is removing it, it's not like it's archiving it, just like deleting something and storing it in a recycle bin. So now I now want to pop it and print popped, then print our number. You would now see that 110 has disappeared. Can you see? 110 has disappeared from our list, but we now found it inside our popped variable. Can you see it here? Can you see 110 here? Please react so that I can know you can see it. Can we see 110 before our list? Hello, can we see the one? Okay, awesome, awesome. So yeah, the 110 here, it's basically like stating that it is temporarily deleted, but I'm keeping it in a recycle bin. So that is what pop does. So pop again, it removes or deletes the last item on the list, but keeps it, which you can actually access it when you put it or print it in another variable, as we have seen now. So another one, which will be the last, I actually have like loads of methods of lists. As I've said before, list is very interesting, right? So, but because of time, I wouldn't want this thing to extend to 9 o'clock. So I will be introducing the last list method you'll be reviewing tonight, and then we can call it a night, and continue tomorrow, right, with other data structures. So, which is the extend method. Extend method. So extend method is very useful when you have two lists. Again, extend method is very useful when you are trying to merge two lists together. However, if care is not taken, you would misuse the extend method. How do I mean? If I say that, okay, we have number, let's call this one number one. Let's say this one is number one. So now let's now say we have number two, number underscore two. So now let's give this one also some items in a list. So let's just give some random item. So I can say, let's say 5, then let's say 5, 15, and 50, 65. So let's add one more, and let's call this one 78. So it's okay like that. So we have another what? Another list. So now what we want to use extend for is you want to now add the items in number two into number one. You want items in number two to be also included in items in number one. That is where the extend function comes into play, right? So now, in order not to make mistake while using extend function, we must pay attention to its syntax. So this is its syntax, right? So here we can now say that, if I just say that, I'll still check the charts. Okay, let me check. I'm still going to check the charts. Okay. So I would say number one. If I say number one dot extend, I say number one dot extend. Now let's see something. Let me see this. Let me see what this prints. Okay. You say number one dot extend, right? So the syntax is now that we would now, okay, I was supposed to comment this. This was what I was supposed to comment. So, and then, okay, so now our print statements will now be what? Number one, right? So we want to print number one. So now the syntax for extend is basically you state the first list dot extend. It now accepts the second list as argument. So in this case, our second list is what? Is number two, right? So what we are saying is add the list in number one inside the list we already have in number two. So now we now want to print our new number one list. Now let's see what we have as our new list for number one. So can we all see it? What do we have there? So we now have items previously, items of number two. are now in what? Number one as our list. So that is what extend does, right? So that is that by the way. So let me just introduce one more before we call it a wrap. So we can say this, let's see what this does. So do we see what this does? So another method is what we known as what sorts. So the sort method. So initially, if we say we have 10, 20, 30, 60, 70, then we have 5, 15, 65. But I want this to be what arranged. I think this should be ascending. Yeah, ascending order. So it should arrange everything ascendingly. So you have 5, 10, 15, 20. So we also have another one, which is what? That is to arrange it from, like, that should be descending, right? So we can say reverse. So let's see what we have where we print number one. So can we see what we have here? So we have from 110, 100, 90, 80, 78 till the lowest number. So sorts would arrange chronologically from the lowest to the highest, while reverse, as the name implies, would do the same thing from the highest to the what? To the lowest. So basically, we will be calling it a wrap here on today's session, right? So in the course of this session, we started with functions. So in function, we're able to define what function is, the function rationale, the logic, how to define function, the conventions of naming in function. So we also were able to demonstrate how to use how to use parameter in a function, what argument is, the keyword argument, the default argument, the positional argument, right? So we're able to do that and also add on practice. So for those who missed it, this session is recorded. We are going to share this recorded version. It will be available most likely tomorrow, or at least, or at most on today is Wednesday, at most on Friday. It should be available for every one of us to refer to it for what we have missed. So when we all appreciated function, so we now progressed into data structure. So time did not permit, we were able to check other data structures such as tuples, sets, and dictionary. But I believe with this demonstration, so we should all feel comfortable to an extent working with lists. So one more thing I would need to also mention in lists before we wrap it up is iterating. So it's also equally important. So you're going to check that also tomorrow, how to loop over in lists, because many times you want to print, you have lists, like you have long lists, right? You want to loop over, you want to manipulate your items inside a list. For instance, we can actually define or write a program that can add all these numbers together. So we can use that. You can also use a loop, like to iterate through the items and add them together. We can do a lot of things with lists, right? So um basically, this is it for today's session. So if there's any question, please, you can ask now before I attend to the concern someone raised in the chat. So if there's any question, please ask. If there is any question, please ask. If there is none, oops. Please ask if there's any question, please, very quickly. Okay, so I believe there is no question, right? So in absence of any question, so we'll be calling it a night. I think someone that who even raised that question has left. Okay, so I'm going to stop recording now. One moment. So thank you guys. For those of us who stayed, that's a session ended again. Hello, Victor, can you hear me?
Yes, yes,
Hello.
yes. I hear
Okay,
you.
you can still hear me, right?
Yes, yes.
Okay, give me.
Yeah.
Yeah, give me a moment, please. Just a moment, please. I'm trying to save this recording. I don't know what is happening. Give me 1 second, please. Village people don't come or let us save it.
You see, say no be me.
I beg you. It's very important. Daniel would even ask for it. Daniel would ask for it. So I actually have something I would want to share with us. 1 moment, please. So I'm trying to come back to this thing and save it. So it's not allowing me. Okay, so let me save it. Yeah.